Maybe let's start because the introduction will take a couple of more minutes and hopefully more people will join in. It's an absolute pleasure to welcome everybody to this very timely topic on the principles of responsible application of AI to support advancing climate change adaptation metrics, monitoring, evaluation, reporting, and learning. My name is Srijita Dasgupta, and I am currently working as the lead for climate change adaptation in CABI. We are an intergovernmental organization working at the intersection of climate and sustainable agriculture. But I also have the immense privilege to serve as the co-chair of the International Platform on Adaptation Metrics, or IPAM. We will be hearing from Carl, who is the chair of the steering committee of IPAM, along with being the executive chair of the Higher Ground Foundation and the founder and in charge of tools that innovates under his consultancy with the Climate Adaptation Works. He's the creator of the Climate Vulnerability Reduction Credit Instrument, along with co-authoring the Adaptation Metrics Mapping Evaluation Framework, AMI. And also from Samraj, who is a consulting researcher and the Intergovernmental Panel on Climate Change upcoming, the seventh cycle report, and he's the lead author based the in New Delhi, India. He works in the field of climate change adaptation, health adaptation, nature-based solutions, flood risks, agriculture, and other socioeconomic and ecological modelings and assessments. His work mainly involves quantitative analysis, indicators and metrics, and monitoring and evaluation. He has also been serving as the lead author and reviewer in a lot of esteemed climate related assessment reports under various UN and other government organizations. And these two colleagues have been co-leading this piece of work, which we are very excited to hear about. Over to you, Carl.
Thank you very much, Rajita. So Samraj and I are going to try to, in 20 minutes, cover what took quite a while for us to actually develop with a team in a task group within IPAM, and also with the feedback from a lot of external reviewers. However, this is a living document, so that's why we're having this sort of soft launch, is to really spell out the issues around this, starting with, of course, why we're here and why this is something we feel is very important to consider and develop at this time, if not sooner than this time. Okay, I think most of us have come from the adaptation community, and so we know that adaptation needs are large and growing, and that there's inadequate resourcing of them, generally speaking, around the world, but in particular in developing countries. And the need is growing while the resources seem to be shrinking, at least public resources. And we're focused on metrics. We're focused on seeing how we can understand adaptation risks, adaptation activity, so that we can help to design, plan, create policies, and fund with reason, with quantitative reason, and to understand not just ex ante, but ex post, what's successful. This is going to be very critical, we think. And this is in the light of inadequate resourcing that is clearly something that needs to be addressed. But in the meantime, we're dealing with very under-resourced space. Meanwhile, there's been a lot of good progress at the international level and at other levels, trying to consider, well, what should we be seeking when it comes to adaptation, including the Global Goal on Adaptation, where there's been a 2-year process right now of that's finished, that's looking at identifying the indicators that can most appropriately deal with the thematics and the domains under which global goals should be set for adaptation. But the challenge is really how do you apply it? Also, we should not think of this within the siloed realm of the Climate Change Convention. Consider also how adaptation is really something that transverses society, economies, and the ecology of the globe. And there's also a lot of other initiatives that deal with this. I mean, sort of the mothership of this is this Sustainable Development Goals. But there's other UN mandates, UN targets, and there's also a lot of activity by non-governmental actors and people at other levels in governance. So I've hinted at why we think metrics matter, but I'll try to articulate a little more on this. Without metrics, there's great risk, almost certainty that there will be accountability gaps, and further that these gaps include that vulnerable groups are going to be overlooked. This means vulnerable groups, vulnerable geographies, vulnerable sectors, and there's a finance gap that's in the hundreds of billions. And so the finite resources that we have need to be allocated as efficiently as possible and as equitably as possible to address what we feel are the goals. With metrics, we can track results, we can allocate, and we can strengthen adaptation outcomes. So that's why we care about metrics. That's why there is the IPAM. Okay, over the last several years, in particular over the last 18 months, it seems everyone is talking about something called AI. It's not AI literally as in artificial intelligence, but it's a set of models and approaches and tools that have become much more powerful and have supplanted a lot of work meant in the broad sense, but also in the narrow sense. And it relates to adaptation metrics. Now, there was just a recent survey that was done that asked Americans, and so it's a subset of the global population, but it asked them, well, what are they afraid of? Most people did express serious concern regarding AI, focused on the societal consequences. How is AI going to change the world? How is it going to change the way people interrelate, how economies are structured, and how people, concerned. And the other thing that's very interesting is that even in a polarized society like the United States, there's broad consensus over these concerns. It's not influenced by political views, nor is it viewed is it something where highly educated people have a different set of perspectives, generally speaking, than less educated people. And the key risks that were identified, the three ones that were most principally considered were the spread of misinformation, the potential for manipulation of AI outputs or of AI models and inputs, and also that AI risked centralizing power, however this is defined, whether it's those who create the large language models and the other tools, or those who control the tools. How is that relevant? Well, AI is already being used to support indicator selection and use. It's used in modeling or to support modeling and in a lot of monitoring, evaluation, reporting, and learning processes. And you see, if you're at all involved in this space, that there's a lot of discussion of how AI should be used or can be used, or opportunities, or what have you. AI outputs clearly can influence decisions on funding. And thirdly, there are risks of biases and errors that could lead to maladaptation. Now, when it comes to adaptation metrics, trust in what one's trying to measure and the goals that one set is built on reliable and credible metrics, right? So what's the implication of this? It means that when we're applying AI, it's important that we get this right. There's a lack of specific uniform user standards for adaptation metrics, indicators, and monitoring, evaluation, learning, reporting. And there's potential that the outputs that are used for decision making are either unclear, insufficiently broad, or unreliable. And so having principles we feel is essential if we're going to deploy AI responsibly for the good of vulnerable communities, vulnerable systems. Now, let me just quickly let those of you who aren't involved with IPAM know a bit about it. So IPAM was set up in 2020 after years of preliminary engagements and conferences to address the issues around how do we get adaptation metrics right. It has grown as an organization to now comprise 190 individuals in nearly 50 countries, and we have 20 member organizations. What does it do? We host a lot of convenings that try to get together diversity of experts that have different sectoral and other perspectives and geographic and cultural perspectives to try to understand how adaptation metrics apply in different contexts. We develop common policy papers, research and frameworks. For instance, we developed the adaptation metrics mapping evaluation, and it's being applied now in a variety of different contexts. We engage in a variety of different global and regional initiatives. We have been involved in a few UNFCCC submissions and providing technical advice in various processes involved in the COPs and other things like that. And more recently, we've convened a group of well over 20 of our members to co-author the Global Adaptation Metrics Report that included activities like a conference on this, a policy paper that was used to inform at the COP, at the latest COP, and we're forthcoming developing some articles that should be released on specific areas of our work. Now, over to you, Samraj. I believe it's time to talk about the principles for responsible application that we've worked on.
Well, thanks, Carl, for that introduction and also setting the context, especially the summing up of the AI fear in just one slide. And I would say that that's perhaps the motivation, or that really led to the development of this document that you're seeing here, which is basically involves the come up with the principles for responsible application of AI or adaptation matrix and more. So next slide. So basically, we decided to have these principles specifically for adaptation matrix because that's our mandate. And we were very clear about it that we are not going to have it for the developers, but for the end users. This end users includes the policymakers, planners, NGOs, evaluators, donors, researchers. And the aim was that to help them in selection, configuration, and verification. And we were clear that these principles should be applicable across the AI tools, ensure transparency and AI use, and can be adapted to the local context as well. So the document that we have come up with is actually a living document, and we intend to iteratively update it as and when the technology, laws, and policies evolve. So next slide. Now, as you know, there is a growing importance of AI, especially for the metrics and world, to measure the progress of GGA. And this, of course, comes with associated risks. So there was a clear-cut need for the guidance on appropriate use of AI. And the document that we came up with actually intends to define the key risks and come up with a set of principles for safe, credible AI applications that ensures equity, transparency, and scientific robustness. So the idea was not to come up with a specific set of guidelines or step-by-step guidelines, but to come up with a sort of guardrail or a broad guidance to leverage the benefits of AI for achieving the adaptation goals. So next slide. You can skip this. Next. Yeah. So before we get into the barriers and challenges, I'd just like to just articulate here that AI has got a potential use in the across adaptation cycles and across the different phases. As you can see here, if you look at in the IVRS step phase, AI can be used for identification of the indicators and most importantly for the synthesis of the evidence for impact, vulnerability, and the risks. It's very useful, especially in case of collection and analysis of the complex data sets like the geospatial data that we have, remote sensing data, and to identify the high risk areas or for the vulnerable areas, and especially for the tasks that require high computational powers, especially like the predictive modeling for the future risk assessment. It can also, if you look at the planning phase, in addition to identification of the indicators, it can be very instrumental in deciding on the most effective adaptation measures, and that could optimize the resource allocations. Well, if you go for the implementation phase, it just not just identify the indicators, but also help you evaluate the different policies that has already been placed or that is proposed to be used, and streamline the project management and track the progress. And this would eventually support the timely completion of this project and also make the project more cost effective. Then coming out of the last phase, which is the MEL, which is the most important phase, or measuring the effectiveness of the entire adaptation measures. Here, AI has been very instrumental in identifying the indicators for both the monitoring as well as for evaluating the progress of the adaptation measures. And of course, incorporating the learning or making the adjustment. Another important use here is of AI is very helpful in case of reporting, and it fulfills the needs of reporting the different UNFCCC processes like NAPs or the NDC or BTRs or even for the GST and GGA. So if you look at the overall, that AI do have a potential in fostering adaptation, but this comes with several risks and challenges. And because of these challenges or the concerns that we had, we decided to come up with these principles for responsible use of AI. So now it's over to you, Carl, to take us through the barriers and challenges.
Yes, thank you. So we've divided up the challenges, the issues, into three broad buckets. They're all related, and in some senses, you could say that the ethical challenges, well, it's ethical challenges, it's governance challenges, it's capacity challenges, but they're all related. You could say, well, why isn't this an ethical one? It is ethical, something in governance, for instance, but this is the way we've tried to organize it. And when we talk about ethical challenges, what we mean is really, are the data out there most appropriate, for the most vulnerable, and so on. So there's four broad areas you can consider. We can talk about, is there availability of high quality data or an unfairly allocated or not sufficiently comprehensive set of high quality data? If it's not comprehensive, and it won't be completely, then it's going to bias the choice of metrics and the evaluation results. Another issue is that experiences so far have shown that AI models tend to be less efficient in climate modeling and scenario simulation. And this can result in poor data quality. And it comes from poor data quality, where you may need a higher level of granularity for the data to be able to do good modeling and good scenario simulation. And that doesn't exist. And so if you're trying to use it for that, it may actually be an issue and the outcomes are going to be unfortunate. There's also a concern over security and privacy concerns related to the data, as we don't really have a full understanding over where these data may come from, what the outputs are, and is it going to be private, especially socioeconomic data. And then finally, there's something that I think all of us have probably are aware of, and that's that AI large language models do something called hallucinate, where because there's insufficient or biased training of the models, means that what comes out of a prompt oftentimes lacks the clarity and the detail. And so that particular outputs could be treated with a sense that this is true when it's a falsehood and it's plausible. And so, do you actually know if all of the outputs are actually true, literally true, in a factual sense? The second set of issues that we are trying to address through the principles relate to what we call governance. And what we mean by governance, of course, is related to are we managing the particular ways that AI works? And so, is AI perpetuating biases through the training data? And it can often do that. Because of the imbalance in the inputs available to come up with a comprehensive, if that's the word, sort of sense of the inputs, and then comprehensive and fair, balanced sense of the outputs coming from a prompt. There's also issues related specifically, connected to this issue over regional disparities in terms of what adaptation focus is out there, and also in terms of what indicators are being used. And it could be that there's a lot more information trained in particular areas where that information is found by large language models or has been trained than elsewhere, which is a concern and a risk. There's also a concern that data sets may be biased in that they may overlook or underrepresent different perspectives in different groups, gender, age, all of the ways that we divide things up, including, of course, also socioeconomic status, where oftentimes the information that's being used is imbalanced, perhaps not towards these groupings, in part because of the resources are perhaps less available for highly vulnerable groups. And this can perpetuate gender and social societal inequities. And then also there's an issue that the outputs could be too complex for a particular user, and even the designers of large language models oftentimes don't know the logic within which the outputs are made. It's a black box for everyone sometimes. Can we overcome these is a big concern. And then the final set of challenges relates to the capacities of the users or those affected by adaptation. So when it comes to those who may use or could use AI, there may be a lack of capacity and expertise, not just in AI, but also in climate change science. And this itself means that to use large language models, if you lack those capacities and understanding, might result in some outputs that are not constructive or possibly destructive. There's a potential for some groups to not be able to ground truth or validate the AI outputs because of a lack of their capacities and knowledge of how these things operate and what approaches can ground truth them. There's also potential for different groups or users to lack the capacity to manage how it's applied within their organization. So you may have certain staff working on evaluation or metrics that are doing things that maybe you can't really manage, you don't know about, and this can really change the decision-making process or result in issues with that. And then finally, communicating the output coming from AI is something that is important to know how to do. when you're dealing with stakeholders who are the vulnerable. So I'm going to turn this back to Samraj, who's going to try to spell out the prioritization and then spell out the principles that we are forwarding on adaptation metrics. Over to you.
Thanks, Carl. So, as you know, that the challenges related to the use of AI basically is broadly categorized into three. That's ethical, governance, and capacity. So, keeping this in mind, we try to come up with a list of or a set of principles to address each of these challenges. And because this set of principles were not equally important in terms of the importance, so based on the risk mitigation policy value, the visibility, the potential for harm, if ignored, we classified this or this categorized these principles into three categories. Some of them were essential, that is, they are non-negotiable or the minimum standards, and they are mandatory. While some of the principles were important because they strengthen the quality and trustworthiness, while some fell in a category which is more like a desirable or aspirational, or that are best practices, and they are applicable only in case of availability of resources. So next slide. So if we look at the first channel, which is the first challenge, which is ethical consideration, the first and foremost principle would be to ensure that it's used to augment and not as a replacement for necessary human expertise. And since most of the challenges are related to data quality, security, and privacy risks, so the principle requires to establish a robust data governance framework that would ensure availability, accessibility, and high quality data, which is very essential to address the equity issues, because most of the equity issues are they are embedded in the quality of the data. Then there's a need to have policies and procedure for data collection, storage, usage, and most importantly, the traceability. Because the traceability of data is very important to find out if there is any bias or if there is any sort of the source of inequity. Now, once you have this AI deployed, your system becomes more and more vulnerable to the external risks, such as cyber attacks or a security breach, or maybe a manipulation of the algorithms of AI. So keeping that in mind, to cope up with such external risks, there must be a backup plan. So there must be a system or a mechanism for a backup plan, or where to fall back in case of any risk, any such risks. And the user should also ensure a regular assessment of the legal compliances, because that keep on changing and evolving, and also with the relevant national and the international directives. So next slide. So the principles related to the governance basically addresses the challenges related to biasness, equity, trust, access, and accountability. So to address the biasness, the user needs to identify and actively address the potential biases, and not just address the biases, but also disclose if there is any potential bias, and also to disclose the methodology or that has been used for decision making and the data and the process to maintain the transparency. And as far as the accountability is concerned, the user needs to have a system or a mechanism in place for the human oversight, and keeping it with the notion of assisted intelligence over the autonomous intelligence, there needs to be it should be mandatory to disclose the extent and scope of the human oversight. Another problem, as mentioned earlier, that is of ground truthing or validating the data that has been used for this training purpose. So there should be a mechanism for the ground truthing, and that should engage the key stakeholders for the consensus on the data indicators and the social acceptability. Another key aspect of adaptation measurement is having a MEL system. Since MEL is most important in measuring the progress of the adaptation, so there must be a clear guideline or instruction on how or where and to what extent AI is integrated in the MEL system. Now, one of the key characteristics of adaptation is context specificity or contextualization. So to ensure this, the user must select and customize the AI tools depending on the needs, scope, and the scale of the adaptation, as one size fit for all doesn't work for adaptation. Then there's another which should be highly prioritized is the use of explainable AI. And there are several explainable AI techniques like LIME or SHAP. So these actually inform that what's going on behind the scene. The user get to know that how the AI is making a particular decision, how it is coming to a decision on a particular indicators. So this really this brings out the credibility of the entire process. Yeah. Then there should be a mechanism to monitor the AI performance and unintended outcomes. That's just to avoid any maladaptation. So next slide. Next slide. Yeah, thank you. So the last challenge was of the capacity, and here the one of the problem, the major challenge is of interpretation. So there needs to be a training for the many professionals and the other stakeholders to enhance their AI literacy for effective interpretation. The other important point that needs to be taken care of is how do we report? This the AI reporting for a scientific community may not be suitable for the other stakeholders like civil society or maybe a policymaker. So the outcome of this AI needs to be customized as per the target audience. Then it also requires a framework for knowledge exchange, technology transfer, and capacity building. And finally, there should be specific guidelines for the application of these principles. So it's over to you, Carl, now for explaining the next steps.
Sure, sure. So this is a work in progress. And as things are changing so much in the AI space, it's going to continue to be a work in progress so long as we humans are involved in metrics and neural. But what we also need to do is develop something practical about how you can actually implement these principles. And we need to further use the three-tiered framework to prioritize these framework that Samraj has already conveyed. Now, needs to, of course, as noted, recognize the constraints. That's how these three tiers are set up to deal with user needs, capacities, and resources. And then also, we need to make sure that we create guidelines that connect to implementation, right? And that people, I mean, it's all sort of like you can't use the Constitution necessarily to come up with a rule over air pollution necessarily directly without thinking a lot. And so we've got to do a little bit of this work to think through things. So what we're going to be doing is inviting use cases and also be involved in consultation and surveys to try to build up pathways for how you do implement. And this includes evaluating, validating, refining the principles, but also getting those specific guidance in place. And so that's what we are at, and that's what we have right now. And I'd urge all of you to get in touch with us if you want to engage further. But I'd also urge those of you who aren't already IPAM members, and if this is a space that's relevant for you, to join IPAM. And so here's where you may. With this, I pass it over to Srijita to introduce the discussants.
Yeah, thanks, Carl. Sorry, I'm just trying to look from my screen. Okay, there you go. Yeah, so thank you very much for presenting the work you have been doing. We do have a quick question in the chat that is something that I'm also not aware of. Is the paper readily available, or is it something we're in the process of publishing? Or if you could come in quickly.
Yeah, it's something that we're in the consultation phase now. I think based on the feedback from this, we're gonna advance in terms of making this more public, right?
Okay.
Yeah.
All right, that's good to know. So if anybody has any comments on feedback, please do share them in the chat. So in the interest of time, we will move over to our next segment, which is the panel discussion. It will be led by Carl, but I have the pleasure to introduce our speakers. We have Dr. Suzanne Moser from the US, who is an independent scholar and consultant whose work focuses on adaptation to climate change, the science and policy interactions, climate change communication, and very interesting, the psychosocial resilience in the face of traumatic and transformative challenges associated with climate change. She's also a co-editor with Max Boykov at the University of Colorado Boulder for an award-winning edited volume on successful adaptation, and is building on that foundation work. She's the creator of the Resilience Metrics Toolkit. We also have Dr. Anne Sietsma. We also have Dr. Anne Sietsma, who is a climate justice officer at the Climate Policy Radar based in London. It is a nonprofit organization that builds databases and AI-powered tools to support informed climate action. One of Anne's roles is to develop responsible AI guidelines that are practical yet ambitious. And before joining the CPR, he was also researching on tracking global adaptation, including AI-based indicators. But it seems Dr. Mohammed El Gabri is not able to join, but he was a third speaker. I thought I had seen him.
No, I haven't.
He's there.
Oh, yeah, okay. All right. And he serves as the director of the African Disaster Mitigation Research Center at MIR, at the National Research Institute of Astronomy and Geophysics in Cairo. He has over 2 decades of extensive experience in natural hazards monitoring and modeling, and his distinguished career encompasses both academic teaching and professional consultancies. So it took me a while to introduce the 3 panelists, which really, probably alludes to the rich experience they will bring into the panel discussion. Over to you, Carl.
Yes, thank you, Srijita. We have prompted the discussants with sort of issues and questions that we hope they can address from their different perspectives. So I'm just going to ask, Anne, how do the proposed principles apply? How could they apply in reality? Are there any concerns you have on them? And are they comprehensive given your experience in different contexts, given that you've worked a lot in this space and broader spaces? So over to you.
Yeah, thanks, Carl. And thanks for giving me an advanced version to read. It's been a pleasure. I think it's really hard to write something that's comprehensive in this space, right? Because there's so much happening and it's changing so quickly. And so well done for taking a punt at it in the first place. And there is a lot of richness in there. I think where it becomes difficult when you're applying these kinds of things is in trying to figure out things like trade-offs, right? And to make that very concrete, for example, one of the classifiers that we've been developing is trying to figure out what countries are doing to enable adaptation, right? So the sort of first phase of that adaptation policy cycle that was shown. Do we have meteorological associations? Are we investing extra money in those kinds of places? Are there adaptation framework laws in place? All this kind of stuff that isn't by itself adaptive, but that it enables adaptation down the road. And we can build a very simple classifier with a limited machine learning, mostly based on things like keywords. And when we did that, right, we have as a principle, we want to use AI sparingly and the smallest model we can get away with in general. So we tried it with a very small model, and we got scores that were not so great, right? 70%. But the model meets a lot of your kinds of guidelines, right? It's very auditable, it's very transparent. The resource use is low, the explainability is very high. But we thought, 70% of one scores, let's try a really fancy LLM model, right? The fancy LLM model scores 90%, is much more context aware, gets much richer data. And so it's much more comprehensive in the kinds of things that it shows, and it's particularly better at bringing out examples that are maybe written down less clearly from low resource areas or these kinds of things. So scoring really well on some of these other kinds of indicators that are also included, but much more opaque, harder to audit, much higher resource use, right? And so do we get the 70% model? that is very light and efficient and transparent, or do we get the 90% model that is less efficient and heavier? And I think it's in these kinds of sort of weighing where the rubber really meets the road, and where you know, you need to almost have a bit of a prioritization of these kinds of principles, which there are 3 tiers in here, right? And so there is a little bit of that, but even within that, you can't always meet all of them. And I think having a good sort of rich understanding of exactly what kinds of users need to be using this and what principles take precedent for your specific use case, that's always where it gets really, really complicated. And so for generic guidelines, of course, you can't capture that. I fully recognize that, but I think that's really when people will start to interface with this, that's where they're going to find the trouble, and that's good trouble to be in. Yeah,
it's perhaps it's necessary trouble. I thank you. I mean, I guess your point is, do you throttle it to the point where you meet this high standard, or you get more out of something that's a little bit a little more wild and crazy, or you don't really know what's going on? Yeah. Great points. Thank you very much. I'm going to pass it over to Susie to try to address the question, how do these principles, based on what you've taken on board so far, and I know you're also a part of the task group, and so you've been involved in this as an IPAM member, but how do they support or don't support or miss-supporting a lot of the key monitoring, evaluation, learning, reporting tools and approaches for adaptation that are out there that need to be interfaced with this somehow?
Yeah, big question, Carl, and thank you for having me. I'm not sure I'm the right person to answer these questions, and I'll say that with acknowledging that I come to AI with an extremely critical lens of the entire enterprise, because we know there are undeniably negative consequences of developing AI in the first place on climate, water, land. In other words, making the very problem worse we're trying to measure progress and success on, right? Yeah. It is undeniably unethical and biased in how it was constructed in terms of the extractive nature of gobbling up other people's intellectual property to then spit it back out. And then, as you already acknowledged, perpetuating the recognitional and procedural distributive justice issues. And it's undeniably negative that what we're learning from cognitive science and neurological enterprises of how it affects people's thinking. In other words, using AI will make us worse at thinking about and solving the very complex problems we're actually accelerating right now with this technology. So that's sort of the starting point, okay? It's a little bit like putting makeup on Trump, it doesn't make Trump better. Anyway, I'll digress. I was a little confused about you said in the paper that this set of principles is for users, and I wasn't quite clear what kind of user you had in mind. It sounded to me more like, what Anne just described, like actually for people who develop AI applications. Because if I think about a user of this technology, it's planners, NGO, whatever that you describe, right? It's people sitting on their computer and typing in, find me some adaptation metrics. They're not going to go through the whole process that you just laid out, right? And all this beautiful work. If they went through all the layers you added onto the adaptation process, you would just burden them more. But what they're looking for is ease. They're looking for, make it faster, make it easier for me to find solutions. So if I were to, suggest how this could be made better, it is to start with the user profile. Literally sit down with somebody who wants to use AI in their adaptation work and follow them to see how do they use it and where can you insert into that process elements of any of these principles. Otherwise, I feel like it's just adding, it's kind of echoing what Anne just said, adding a layer of complexity to an already difficult process. And as you say, they don't have the capacity for it to begin with. I mean, the idea of setting up a data governance framework, I don't even know what that means, right? Like, what would that mean for someone who is, a planner in a little town somewhere? I'm sorry, I just can't see how it will work. But that, having said that, I think the challenges, and let me just say, I've had two experiences of seeing how AI is used. One is to essentially take busy work out of human governance processes, like, where you need to phone someone to get, being forwarded 7 times to get a piece of information. That stuff could be made easier, right? By simply accessing information more easily where it is available. I'll add in parentheses. So those kinds of efficiencies can free up human capacity to do the work of adaptation. And I think that would be really important. I've done some application of it myself, just simply searching for the outcomes of adaptation to see, what has happened. And the benefit I've seen is that AI remembers what humans forget. In other words, what happened 5 years ago? I don't know, but AI has it somewhere in its storage, right? So it's an extension of human memory, if you will. However, it lacked every inside story of what happened. It didn't have any critical edge and, all the other problems that you laid out. So I think the amount of training that is necessary to make this useful is comparable, if not bigger, than any other technology, every other tool thrown out at people, right? And the last thing I'll say that I find most critical in my work with adaptation, developing adaptation metrics, is that it has made adaptation better to go through the whole process, and to integrate development and thinking about outcomes and metrics from the start of planning. That has made adaptation better. The idea of let's just do adaptation here, and then at the end, let's see what we can find in the, unknown black box universe of metrics to tell the story, is not going to do that. So I'm actually worried that yet another tool that promises wonders will take away from the very productive process of going through the development of, going through the process of developing metrics. So I think it's well intended what you have here. It's super aspirational. I don't think it's user driven or practical at this stage. So I'll leave you with that pretty critical bias.
Thank you. This is exactly what we need. And as we did note, this is the start. So we came up with this structure of what we think would be, really ideal. Now we have to test it. Now we have to get user cases. Now we have to say, well, how can we develop this? And so this input is really helpful in that, both of yours. I'd like to pass it over to Mohammed to address this from his perspective on how the principles could apply or are not relevant based on your work on modeling and monitoring natural hazards for disaster mitigation. Being aware that those inputs are critical for adaptation planning. So over to you.
Thank you, Carl, and thank you, Samaraj, for presenting the whole document and the whole points. And I would find particularly strong in this the recognition that AI is being positioned not as a solution in itself, but as a tool within the adaptation matrix and monitoring, evaluation, reporting, learning ecosystem. This is exactly the right frame we have to think about AI location. And it's AI add values across adaptation cycle, particularly in my field from data integration, predictive models, and monitoring. In practice, we can integrate different data sets. We can integrate satellites, ground observation, socioeconomical data, and we have better understanding. Before this was very complex process. Today, it's make it much easier. Also, detecting weak signals in very noisy data. This is very important as well. And of course, generating rapid impact scenarios. These scenarios is really something AI is very good in it. So in this terms, these capabilities can significantly improve the timeliness, scalability of the adaptation matrix. However, we have to be careful about making clear distinction between 2 points. When we are using AI for an analytical support, as I highlighted in this point, or when we use AI for decision grade metrics, this is where also we have to be careful, because when we are taking AI to decision matrix, we have to be concerned very much, because we have a lot of shortcomings which could affect much on this. I would like to highlight some critical gaps that are especially important from hazard and risk perspective. First one, physical validity, because AI system can produce output statistically consistent, but physically incorrect. In hazard modeling, this is fundamental limitation. The process are governed, because our process is governed mainly by physics. You could have data that fits, but physically has nonsense. Also, the problem of failure to under extremes. And this is very important in adaptations and in climate risks, that most AI trained on historical data, average conditions. So adaptation planning is concerned about extreme events where these systems are often least reliable. Thirdly, it's about the biases. Of course, you highlight biases, but I want to emphasize that many of these AI systems are being trained in a very rich environment data. So usually it fails in regions with data scarce regions. And for example, in Africa, in Asia, where adaptation needs are highest, we have less data. So the systems are really biased towards regions with more data. Finally, the last point about this is uncertainty in decision making, because in adaptation planning and decision depend not only on expected outcome, but also what's the confidence, what's the variability, what's the worst case scenario. So all of this has to be taken into account. This gap suggests that some principles could be further strengthened, particularly in 3 areas. Physical and contextual validation should be explicit, not implicit. Uncertainty, transparency should be mandatory, and ground truthing should be defined as a continuous process, not one-time check. This is especially if these principles are to guide real-world systems, let's say. I would like to emphasize a key risk, the risk of moving from evidence-based decision-making to AI-influenced decision-making without sufficient validation. So validation is very important. So to conclude, these principles are important and timely foundation. We need to strengthen the context of climate risk and disaster mitigation. AI must remain physically grounded, uncertainty aware, context sensitive. Otherwise, we risk producing adaptation metrics that are precise but not reliable. And in our field, reliability is what ultimately determine whether decision reduce risk or unintentionally increase it. Thank you, Carl.
Mohammed, thank you so much. I think you conveyed a lot of issues regarding the data. It's the data, right?
Yeah.
And this is, but then how does it match up with this often black boxed issue here. So excellent comments. I think we do need to address all of these. And thanks everyone of the discussants for your inputs. Just one observation before we pass it on to an optional 10-minute forum for Q&A for whoever wants to hang on. But I'd just like to observe that what the discussants have brought to me, at least, is the notion that this work is super challenging. I think the term ambitious was Susie's was a bit generous in a way, but also very, very important, considering how things are changing in this space and how, for good or bad, the reality is that people are using AI more and more. And as these models and as the interface with how humans can use them gets better and better, and the interfaces with different applications, there's a temptation for it to be used more and more. And unless there are governance standards and things like this, boy, where is the world, right? So we're going to be working on this from the perspective of how we can make these usable. That's going to be our next phase. And we very much invite all of you who feel vested in this issue to join IPAM, to engage on these questions. And we'd like to thank you all for your participation, your leadership, your ideas. And my suggestion is there's an optional forum time for anyone who has questions to address them either to Samraj or I, or to the discussants who are able to stay with us. So thank you all. Okay, Anne, I see a hand raised.
Sure, yeah, I thought, why don't we kick us off? I think I just wanted to emphasize that data point a little bit more, right? But also deepen it out a little bit, because I think it's really useful to make a distinction between data that doesn't exist and data that doesn't get captured and can't get captured, and data that is potentially there where AI might actually be an opportunity, right? And so in those sort of three buckets, if we start with that last one, there's a whole universe out there of things like oral histories, right, that are really difficult to transcribe well, that are kind of difficult to access, especially at scale. If we start to think about multimodal models and integrating some of the things that Mohammed was talking about here with satellite data that then relates to social media data, to socioeconomic data, to policy data, and having models that can handle this really heterogeneous sets of data all at once and make interpretations that take these different streams into account, that's very new, right? That didn't used to be an option. That used to take 10 PhDs, 10 years to build these kinds of models. And now it's becoming easier. But that does mean that these two other issues, right, where is the data really missing? For satellite data, it's fairly easy. We have satellite data of every country in the world, and it's not all in the same resolution, but broadly speaking, that works well. But if you start to look at policy, right, the domain that I work in every day, we know that there's a lot more policy on climate change and on adaptation in particular in the countries that need it the least, right? In the sense that a lot of adaptation law in practice is coming from European countries, for example, where it's not that there aren't any adaptation needs, but certainly if you compare them to the potential impacts and already realized impacts in, for example, sub-Saharan Africa, it's not the same, right? And so we're fairly certain that our database of policies is pretty comprehensive, but then there's this sort of second category where we think there might be data somewhere out there and we know that it's in the models and it's hiding, but the sort of influence of the data, or maybe it's even sort of potential greenwashing coming in, right? Where countries are actually trying to influence the way that the public discourse is going, how that influences then the models becomes much more complicated the more complicated those models are becoming. And so when you start to add these three things up together, your data layer is really quite crucial, but it works both ways, right? It's both an opportunity as well as a risk.
Mm-hmm. Thank you, thank you. Does anyone have a response to that or any of the other issues that have been raised during this? I do see that there was a comment that really resonates on this issue over regional data availability in places like Africa. So I think that that really hits it, given that a lot of those involved in this space are also people who are really, development professionals or working on development challenges in developing countries. So I clearly see that this we've got to get our head around how the data is used, how it is abused, how we can know the difference is going to be really, really important. Any further comments on this issue? If not, I do have a particular question that I'm interested to hear if this is the answer. Is this the answer? And the question is, what value does explainable AI add to the responsible use of AI for adaptation metrics? Do you think it brings more transparency? Do you think it does help with trust or address biasness in a way that solves for some, all of these challenges that we're faced? Any feedback there?
I mean, I can take a punt, but I've just been rambling already, so maybe Mohammed wants to go first.
Yeah, Mohammed.
Thank you, Anne. I think it's a very interesting question because as all the speakers now highlighted, it's not about bringing one thing. It's opening new spaces for us. There is a lot of spaces we were not able to go there. It broke this wall. We went there. The risk is, and I think this relates to the question related to the data scare region. Always we have to attribute to the data the uncertainty. Without attributing uncertainty to data and without highlighting the gaps, we will get lost. Always sometimes we need to put an answer. I don't have an answer. Sometimes I have a map with a gap, a wide gap, because I don't have data. So this is very important. Or I have an answer with reliability of 60%, 40%, 90%. So that's what I try to convey in my message.
Okay. Yeah, I mean, can it help there? I mean, any other perspectives on that?
For me, so explainable AI in the sense of if I give a particular model this kind of data, which neurons are being fired, what do those neurons mean, right? Is for the nerds, is my hot take. And that isn't disqualifying, right? Because it's those nerds that are building the actual models. And so it's really a useful, deeply valuable part of research to try to figure out what is actually happening in that black box, to take the adage that AI and machine learning more broadly is just sort of an inherently opaque process with a healthy dose of skepticism and say, actually, most of this is mathematics, and we know mathematics, and we can do really big analyses, and maybe we don't always have the compute to completely pick apart the entire model, right? But fundamentally, that's what we're trying to do. I think that's a really useful thing, to try to build models that are better, that address data in a better way. But I do think it's way too much to ask for 99%, much more than 99%, maybe 3 nines behind the comma of users to understand what explainable AI is about, right? I think it's really important for the kinds of outcomes and to make models that are better and that you have trust in, they are actually better. But for you to understand how they validated that this particular model is more trustworthy than another one, I don't think is particularly necessary.
No, thank you for that. This does raise one other question I've got, and that is, what do we see the future? And when I talk future, I mean, I consume a lot of material that seems to convey that the world's going to be, in 2029, the world's going to be changed, right? You hear things like this. So how much is the relevance of the questions that we're raising right now and the concerns we have right now going to be relevant in 2029. Of course, we it depends on the scenario that we convey for how we address these issues. So we have agency, but what do you think? I mean, anyone, welcome.
I think the friction in the system is underestimated, in the sense that a lot of policymakers barely know how to use Excel, right? And that's been around for much longer than AI has. And it's slowly diffusing through the system now that everyone knows how to use Excel at least a little bit, and that didn't used to be the case 15 years ago. And some of the people even know how to use a pivot table, right? I think we're going to see a similar process with AI. I think the people who are saying in 2 years' time everything is going to be completely upended are underestimating how long it takes for people to get their heads around and start asking the right kinds of questions. Having said that, there is, I think, my main worry is much more in the direction that Susie was pointing at, which is like, how does it change the way that we're interacting with each other with data? What does it do to the social fabric of society to have supercomputers pointed at your brain all the time, right? And to have the nerds who do understand this already play with human emotions and play with politics. And I think that's where my worries are much stronger than for any given policymaker or researcher on the ground.
Okay, well, thank you. And thanks everyone for your active engagement or attention to these issues. A question was raised in the chat over, well, what's next? What's next? Well, we don't know for sure, you know, to be honest. However, having said that, and Samraj, please jump in, or anyone in the AI for AM task group. But as we mentioned, sort of next steps, well, we're going to be working on use cases. We're going to be working on trying to consider how the broader set of people who aren't maybe dealing in this context. And so, and you're kind of in there, but you're also kind of an adaptation guy too. But still, you know, how do we make this usable? And I think one take that all three of you mentioned does relate to user. And how is this relevant for users? And so I think that that's one take home I at least have from this, is that we're going to be focusing in the next AI for AM task group meeting over, well, how do we define the way that we can validate this? How do we define the users, and what in terms of capacities are relevant and necessary for aligning capacities? We've got these, you know, tiers, right? And that somehow relates to capacities, but how do we actually convey this in a way so that it's useful for everyone at some level, right? I think that's a big part of it. When it comes to public presentation of this, well, I'm not sure either, but I would suspect, and I hope that we can do this fairly quickly, is that we can come back with another engagement in months. I'm just going to say months, because that could be 2 months or that could be 100 months, but it better be closer to 2. I mean, is that, you know, we need to really do a follow-up report on where we're continuing to think about both the principles and the use cases and what we're learning, and so that we can further ground truth what we're working on. On behalf of Samraj and I'd like to thank you all for your attention, and until the next time.